y equals the sine of x squared plus x. Inside out method. Take the derivative of this thing times the derivative of what's on the inside. So y prime equals, what's the derivative of sine of x? Cosine of x, right? So then the derivative of this is going to be the cosine of x, but instead of x I've got x squared plus x, times the derivative of the inside. What's the derivative of x squared plus x? 2x plus 1. So then this thing is y prime equals, I'm going to go 2x plus 1 times the cosine of x squared plus x. I can distribute that cosine of x squared plus x, so I've got 2x cosine of x squared plus x plus the cosine of x squared plus x, because this is just the distributive property. Page.
When you say the outside, does that just mean like the equation as a whole?
Yeah.
Okay.
Yeah. It's kind of, when I use that outside inside kind of thing, it's just kind of loosely trying to give you an idea of how to do it. Because this is a little bit easier than going through trying to come up with u's and all that stuff. But that's really what we're doing. It's the same process. Okay. Good question. Okay. Let's try another example. There we go. There it is.
Never mind.
F of x equals x squared plus 3x raised to the 5th power. Okay? Now this doesn't have the trig with it. I could, if I really wanted to, I could multiply that out, couldn't I? I don't really want to. I don't have the time or the energy. I'm a little bit lazy that way.
Can you calculate it?
Lazy?
Huh?
I think it's a lot of work.
But I can use the chain rule. Okay? This is an example of the power chain rule, which basically says take the derivative of this using the power rule. So what would I do with my exponent? Bring it down in front. 5 times x squared plus 3x raised to the 4th power.
Wait, what did that
I used the power rule. Brought the 5 down in front, and then took the exponent and subtracted 1. I'm not done though.
So that's
I'm not done. What do I have to do?
Multiply by the inside.
Multiply by the derivative of the inside. 2x plus 3.
Wait,
Now you're done.
wait.
You can clean it up a little bit.
Where'd you get 2x plus? Is the
Okay.
Oh,
What would you do to simplify that? Would you multiply?
I would just leave it like this probably. I'd say 10x
Yeah.
plus 15, and then just leave it as x squared plus 3x raised to the 4.
if we don't leave it as like the 5 times x squared plus 3, so put like on the test if you want us to.
I'd rather you put it something like that. Clean it up a little bit.
This is going to be on the test.
Yes, this will be on a test.
So that's the answer.
Yeah, that's the answer. That's it. Okay? Does that make sense, Emma? You okay with that? All right. Let's do this. I'm going to put your homework up, but I do want to do one kind of tough problem before I send you off. Okay? I'll put your homework up here just so that, because I am going to run out of time. Your homework for tonight is going to be on page 146. I want you to do problems 1 through 24 again. Let's look at this problem. Let's look at this problem. If we say y equals the tangent of 5 minus the sine of 2t. So now this is a case where you're going to have to use the chain rule twice. So if I want to do y prime, that's going to be what's the derivative of tangent? Secant squared. So then I've got secant squared times 5, not times, sorry. Secant squared of 5 minus sine of 2t times the derivative of the inside. What's the derivative of 5 minus sine of 2t? Well, the derivative of 5 is 0, so I don't have to worry about that. What's the derivative of negative sine of 2t? Negative cosine of 2t times the derivative of the inside, which is 2. So then this times 2. Again, clean it up a little bit. Y prime equals negative 2 cosine of 2t times the secant squared of 5 minus sine of 2t. And that's your answer. That's chain rule.
Is that why it's called the chain rule?
Well, and it kind of reminds me of transitive properties, right? If A equals B and B equals C, then A equals C.
Yeah.
You just kind of piece it all together, right? You can almost think of just,
Well, because it cancels.
yeah, you can kind of think of it as canceling. Okay? Good.